In this video, we're going to learn about pH. I'm Greg.
I'm Julie, and we're the Crafty Winers.
So you've heard about the pH scale. There may be some facts in this video that you don't know about pH, and I learned some things while I was researching. pH, you've heard of it. You know that there's a number assigned to a pH. It's a logarithmic scale. A 5 pH is 10 times what a 4 is, which is 10 times what a 3 is. So it's just like the Richter scale in that manner. The lower the pH, the more acidic the substance is. The higher the pH, the less acidic or the more alkaline is in the mixture. 7 is neutral. A lot of water may be neutral. Ours here in Idaho, at least in our little town, is not, as we'll see here in a little bit.
So fun facts, Coca-Cola is around 2.4, milk is around 6.7, blood is 7.4, soap suds are around 9, and lime water is about 12.5. Not sure why we have blood on that list, but you know, in case you wanted to know that for whatever
It could come in useful.
terrible reason you might need to know that. Like he said, newly opened distilled water is normally around 7, but we found out our tap water is a little bit higher than that. As it interacts with the air, it bonds with the CO2 in the air to create carbonic acid, which then lowers it.
In winemaking, yeast do better in a pH of between 4 and 6. It doesn't matter if it's for red wine or for white wine, they all like that same range. So before you put your yeast into your must, you're going to want to check the pH and make sure that it falls in that range. As fermentation takes place, it's probably going to get more acidic, so the pH is going to lower. But to start off with, you want it between 4 and 6.
So white wine's final range prior to bottling should be around 3.0 to 3.4, and red wine should be between 3.3 and 3.8. And the acidity in the wine will help protect it from spoilage, as well as it gives it that acidic taste. We don't really recommend messing with changing the pH levels unless it's outside of that desired range, because if it's not broke, don't fix it. As you'll see in a little bit, sometimes it takes a lot of chemicals to make just small changes in the number.
So if you're adding either acid or alkaline, say that you add a 1/4 teaspoon, the next 1/4 teaspoon that you put in is going to affect that number about half what the previous one did. At first, it could be big jumps in the number, but then as you keep adding 1/4 teaspoons, because of the fact that it's a logarithmic scale, it starts doing half the effect. We're going to demonstrate that here in just a minute. By the time you get down to the 3s from like maybe a start of 6, or by the time you get up from the 6s from like a start of a 3, the changes that are being made are very, very small.
We'll be lowering the pH here in just a little bit using citric acid as well as tartaric acid. You can also use lemon juice or lemon peels. We choose not to just because of the taste. I suppose though with a white wine, you might prefer a more lemony taste to it, so that would be fine. It's totally up to you, obviously. We just don't use that right now.
Want a lemon Merlot?
Lemon, okay, well not Merlot. Lemon Merlot. I don't know. Maybe we should try it. We've got a lot of things on our list to try.
Yeah, we have lots of Merlot.
Yes, we do.
So you've probably heard of acid blend. A lot of wine kits say to use acid blend, or they give you acid blend. Acid blend is 40% citric, 50% malic, and 10% tartaric acid typically. Different manufacturers may have a little bit different proportions, but that's the standard. Tonight, though, we're using individual acids so we can get an idea of how the taste changes between the different chemicals.
When you're decreasing the acidity, calcium carbonate seems to be preferred for larger reductions, and potassium bicarbonate for smaller ones. Both of them should be cold crashed afterwards, though it's less important for the calcium carbonate. So if you don't know what cold crashing is, it's lowering the temperature to 35 to 40 degrees Fahrenheit for 3+ days. And what it does is it causes particles to sink to the bottom of the liquid.
You want to add the ingredients slowly, regardless of whether it's the ones that raise the acidity or lower the acidity. Put them in small amounts, smaller amounts than what you expect that you need, because if you add too much, you're going to be over the amount you need, and either you've changed the taste or you're going to have to go the other direction and put the opposite chemical in, and it can become a mess. So just go slowly. Take your time. Test after each addition.
Plus, if you're adding twice the chemical, the taste is going to change even more.
Okay, so now what we're going to do is show you using wonderful Idaho water and a pH tester and these chemicals. We're going to show you some examples of raising and lowering the pH level. So you'll get an idea of how to do it yourself. Probably you'll do it in wine. We're doing it in water. The first thing we're going to do is make this tap water more acidic. So we're going to lower the pH. We've got two different chemicals to do that. We've got citric acid and we've got tartaric acid. We're going to start with citric acid. This has only been open for a couple of hours. We're going to get an idea of the pH level of this distilled water. This pH meter was really cheap. It's less than $10 on Amazon. I will link it in the description below. So you turn it on, you put it in the water, swirl it around a little bit, let it stay in there for a few seconds for it to stabilize the reading. It kind of jumps up and down. It is reading 7.02 right now. It's kind of still jumping around. Now it's 6.86. So it's in that 7 range. It may be because it's a cheap pH tester. It does jump around a bit. So that is what we expected. It's around 7 for distilled water. We're going to keep distilled water around because when you're done testing, when you're ready to put the pH meter away, you want to dunk it in distilled water to rinse it and then let this dry upside down before you put the cap back on. Otherwise, it could get a film layer on the little glass reader in there and make it take inaccurate readings, and you don't want that. Now we are going to start working with our tap water. Okay, so we have a gallon of wonderful Idaho tap water. It's a small town tap water, so it's got chlorine in it, we're pretty sure. Probably has other things that they treat it with. So the first thing we're going to do is before we put anything in it, we're going to get that baseline pH of just the water without anything in it. And then we're going to add stuff to it. So my tester turned off by itself. Batteries, I've learned, do not last very long on these, so you want to keep some extras on hand so it doesn't die when you're in the middle of something important. I'll link the batteries down below too. Okay, so I'm swirling it around, making sure that the sensor gets a lot of it. And the reading is 7.74.
Wow, that's a lot higher than the distilled.
Now it just changed to 7.8.
Big difference.
7.82 is what we're going to go with. So I'm going to put the water back in so that we stay at a gallon. And Julie is going to add
a 1/4 teaspoon of this citric acid. Just going to sprinkle that in there, and then he's going to shake it up.
I am overjoyed.
Shaking is his favorite thing.
And I've learned that this is a little big mouth bubbler. Don't hold water very well when you're shaking them. Just an FYI. Okay, so I shook it up really well, relatively well. Good enough.
It was pretty well.
Now I'm going to take another pH. So this is with 1/4 teaspoon of citric acid. I'm putting more in there than I would if this was wine. Okay, so we mentioned in our preamble that it jumps really big to start with, and then as you keep adding the same amount, the changes get a lot smaller. So here's the proof of that. This is now 4.61.
So it went from 7.82 to 4.61 with a 1/4 teaspoon.
For the first one.
Yep.
So now I'm going to put this back again so we stay at our gallon.
And I'm going to add another 1/4 teaspoon.
And then I get to shake it
Then
again.
he gets to shake it again.
We're going to be doing a lot of this tonight. So I'll quit complaining now, or that's all you'll get on your video. Okay, so I shook it. Now we're going to sample it. So the first reading was?
The tap water was 7.82. Then with the 1/4 teaspoon, it went down to 4.61.
Okay, so now we put another 1/4 teaspoon in, and the new reading is 3.8.
So you see that's a significant decrease in jumping there.
We're going to add another 1/4 teaspoon. We do have a stopping point in mind, by the way, but it'll be after you see how much these changes are decreasing as we're adding the same amount. So I will fight with this lid and shake this up and get water all over our floor one more time.
Not just one more time.
Once more. We'll be right back. So the last reading we took,
it's 3.8.
we are now at 3.44. Okay, so this is the fourth 1/4
teaspoon.
and we're now 3.26. Okay, so probably our final. I want to go with 3.17. That's what we're going to say it is. So we're stopping with the citric acid, but look what I'm doing here. I'm going to save this. You may or may not be able to imagine why I'm saving this. We'll come back to it later.
Things that make you go,
Now, we're going to take this acidic water, 3.17, which is about where you want white wine to be, just coincidentally. Maybe it's not a coincidence because I kind of planned it. So now we're going to use calcium carbonate to take the acidity back out again. I think we mentioned earlier that this is the active ingredient for Tums. So this is basically what Tums does to your stomach. It takes the acid and neutralizes it. So the amount on this to make approximately the same jumps in this 1 gallon water as what the citric did going down, it is a teaspoon to go back up. So we're going to do exactly the same process.
except for using a teaspoon.
I'll probably speed this up a little bit more so that you don't have to sit through the whole thing, because I think you probably can see what's going to happen. But we're going to do it all and take this back up to the 7 range. 1 teaspoon at a time. Did I mention how much these little big mouth bubblers leak when you shake them? It's not good. So this got a little cloudy with just the first. It's going to get worse. And this is what you are putting in your wine. With the cloudiness, the reason that you cold crash these ingredients is because when you cold crash it, a lot of this is going to sift down to the bottom. Our last reading was
3.17 before we started this process.
We are at 5.06. So as we mentioned earlier, the first jumps going from acidic to non-acidic also start fast. Kind of weird, because they aren't going to stay big jumps like that. We are now at 5.96. Now it's going to make a liar out of me. 6.05 it switched to. Let's go with that.
Okay, 6.05. So with
definitely want to stir it long enough, and then if you don't like the reading, just keep stirring it. It might change. You might like it better. You might like it worse.
Did he mention this was cheap?
I don't know. I mean, maybe this is as good as the expensive ones.
Who knows?
What it's saying right now is 6.5.
This would be the 4th teaspoon.
Pretty milky. So if this was your wine must,
Ew.
and you were trying to take it from 3-ish to 6-ish, this would be off coloring definitely your wine must. So, or God forbid, if you're doing it at the final stage before bottling, it would be yeah, not pretty. I wouldn't do it. 6.68, 7.02, or 6.86, depending on which one you want to trust. It's staying on 6.86 longer now, so it didn't take it up quite as far as the other took it down. But if you had a target in mind, you might have to keep adding, and you may get a little bit more milky. So we are going to stick one of these aside.
Again, things that make you go,
And I'm going to rinse out this real well and put tap water back in it, and we'll start over with Tartaric acid. Okay, so now back to our Idaho tap water, and we are going to do the same exact thing we just did, but using tartaric acid instead of citric acid.
Again, another 1/4 teaspoon of this as well at a time.
Unless you're at like 6.5 and want to go to 6, in which case, as we demonstrated, there's a huge jump when you're up that high the first time. So don't use a 1/4, use a whole lot less to start with. It's the same tap water.
So it started at 7.82.
Yeah, let's say 4.52. So then
the citric acid was 4.61.
So teaspoon, a 1/4 teaspoon for this and the 1/4 teaspoon for the other are close to the same outcome, which is good. It's less confusing for people like me.
You don't get confused, do you?
Ever. Luckily, we don't have blooper reels.
Yet.
3.5 compared to
3.8 on the other one.
3.17.
Whoa. So it actually lowered it faster.
We did 1 fewer.
And still got to 3.17.
Which is odd. That's I am confused because it was kind of keeping up. The two were keeping kind of similar until this one, and it jumped. So again, be sparing. I did read horror stories from other people in forums saying that that's what happened when they were working with their wine. So add the ingredients very sparingly, because if that was too low for me, I would have to do the opposite to pull it back up, and you wouldn't want to get into that mess. We're going to stop there because of the way that it turned out. So we're going to keep a sample of this Tartaric for later.
Now we are going to use the potassium bicarbonate to raise it back up.
So this, definitely when you use this in your wine, because before primary fermentation, you may not have to do anything special, but I think the safest thing to do if you use this prior to bottling is to cold crash it. Crystals sometimes will form in the wine when this bonds with other ingredients. So safer than sorry.
And this seems to be stronger than the calcium carbonate, so we're going to start with a smaller. We did a teaspoon on the calcium carbonate, so we'll do a 1/4 teaspoon on this one.
Okay.
It's granulated, so I guess that makes a difference.
3.89.
Okay.
4.7.
Okay. So this is 1/4 teaspoon number 3.
6.14. Unexpected jump. Small amounts, guys.
That's why we do small amounts.
You just never know. This stuff is hard to predict. That's all I can say. 6.68.
Okay. And that is really weird, because after 4 teaspoons of the calcium carbonate, we were at exactly the same. So this is 4 1/4 teaspoons.
That's not that big of a coincidence, because I see that the numbers, pH numbers, get repeated a lot. I don't think there is a 6.67.
Oh, okay.
It's 6.68. I don't understand that part yet, but I've noticed that through my testing.
So at 4, we're at the same point as we were with 4 of the other.
We're doing one more.
One more.
Uno más.
But the measurement is definitely smaller on this product.
It isn't as predictable. The bicarbonate,
yeah, it was really
predictable.
This would be number 5
Number 5.
5 1/4 teaspoons.
If I was going to guess,
Don't guess.
Guess it's going to come out the same as the other, which is 6.86. But this one has been harder to predict. Not in this case. 6.86.
Oh, there we go.
So that came out perfect using a 1/4 teaspoon of this versus a teaspoon of the calcium carbonate.
Yeah.
That's, I say, the increment that you probably can be the standard increment for trying to, oh, we are doing something with this.
Yes.
You may have that.
Oh, thank you.
Okay, so we are done with the pH meter. So what you need to do is rinse it out in distilled water. I'm going to do that before we go on to our next activity. Now we're going to actually taste what these taste like. This one is the citric acid.
That's the tartaric acid.
So we were going to do shot glasses, but so it's a little lemony. It's almost like a really super diluted lemonade with no sugar in it. So that was a 3.17 pH?
Yeah.
I don't know that I would want, I mean, it's not extreme, but there's definitely a citrusy note to it. So I think that would be fine in a white wine, probably.
It tastes like lemonade flavored Kool-Aid with no sugar, super diluted.
And all of the ice cubes melted.
Yes.
It's not terrible. It's not really strong. I mean, for 3, it's not a flavor that I'd want in most of my wines. So this is the Tartaric.
It's kind of like extremely watered down lemon juice. It doesn't have that lemonade-y taste to it. It's more pure.
Yeah, this is not as strong. 1/4 the strength of the flavor of the other one.
It tastes more natural. That tastes more fake. That's why I said it tasted kind of like Kool-Aid.
Yeah, I can go for that.
Yeah.
So this one, if you're not wanting flavor, Tartaric is definitely the way to go from those two. So this keeps settling. We keep having to stir it up. So this is the calcium carbonate, obviously. Again, it's what Tums is made out of, and maybe Rolaids. Who goes first?
I'll let you go first.
This is pH of
6.86.
This is close to water. So this has got the citric acid that made it acidic, and then we neutralized it using calcium carbonate. And honestly, it tastes like water pretty much to me.
Well, I guess that's good, right?
Maybe there's a little bit of a chalk taste.
It tastes like distilled water. Like it has no, you know how purified water has kind of the minerals kind of in it? Even your purified water from the fridge has a little bit of it kind of gives it a sweetish taste. Sweet-ish, not Swedish.
Like from the Muppet?
No, sweet-ish. Just a little bit on the sweet side. This tastes flat, just absolutely flat.
It's not unpleasant. It's not, I mean, I wouldn't be afraid of putting that in my wine.
No, I mean, it has no flavor.
It looks a lot worse than it tastes.
It looks like Alka-Seltzer, but it tastes
It does.
nothing like
Alka-Seltzer. Yeah, but there's no fizz or plop or anything.
No.
Last is our
Potassium carbonate.
tartaric acid and then potassium bicarbonate.
Yeah. This stuff.
That stuff.
Okay.
If you're worried about color, this one is the one to use.
No, I don't like it.
I don't want to try it now.
After tasting this one, that's a lot different.
Also similar to water.
It actually almost you know what? I bet you this is one of the ingredients in Alka-Seltzer. It has that aftertaste to it. But don't you recognize that kind of little aftertaste? It's a lot stronger in Alka-Seltzer, but there's something there.
There's a little bit of a unnatural taste. I don't want to say chemical because it's not very strong. But again, it's not terribly unpleasant. But color-wise,
yeah, it looks like water.
If you're concerned about color of your wine, this will settle out. We kept having to stir it because the white sinks to the bottom. So hopefully the white isn't actually what's affecting the pH, because if it settles to the bottom and you rack it off, you got your acidity back. Yeah, it's just as we speak, I can see particles on the side of the glass.
Yeah.
It's already settling at the bottom. So the color probably fixes itself when you cold crash. That's all we wanted to show you. Now hopefully you have a little bit better understanding of pH.
This was the most exciting tasting we've ever done. Tasting water.
No alcohol in that stuff.
Rude, we're gonna have to take a drink now.
Yeah.
Just to counteract the water. Well, thank you guys for watching. If you liked our video, please press the like button and leave a comment telling us what you liked. Ask us any questions, we will answer you. Hit the subscribe button and tell it you want all notifications. And thank you, and we'll see you next time. And cheers.
Cheers.